Now, delete. How do you delete? Okay, delete is more interesting. Okay, the structure of delete will be the same as insert. Okay, but now the problem with delete is how do you restructure the tree? Okay, now how do you delete? So let's make it void. Remove. I cannot use delete because delete as a keyword. I have to use remove a key, and we know that this is not a const function. And again, I'm going to call the private remove. I have to start removing from the root pointer, and my private remove would be down here, const key and node pointer alias post. Okay. So how do I know that I have to delete now? When I'm trying to delete, I know that I will find a match. Okay, so what would be the easiest way to do this? Because apparently, in order to remove, I need to call search, right? I need to call search, but then when I call search, what do I get from here is a pointer, okay? But which pointer?
The current position.
Pointer to the current position, okay? Yep, so that's good. So I can now call search. Okay. I think I'm going to do it this way. I'm going to do it this way.
Why are you using the two-parameter search?
Okay, why do I use the two-parameter search? Because I need to start searching from the top, right? When I try to delete a node, I need to know where the location of that node. Okay, and then once I know the pointer to that node, then I know that node has to be deleted. Okay, and then from there I need to check whether it has one or two children, right?
Right.
Are you still with me so far? Okay, so now I'm changing the signature of my remove to take only a position, just a pointer. Okay, and what do I do here? Check if the easiest case is if both left and right are nil, right? If left pointer is null and right pointer is null. Okay, this is a node with no children. So when the node has no children, what do we do? And the parent pointer is in post, right? Are you with me? Still? But before we had set to null, we need to dispose. Otherwise, you're going to get memory leak. We want to deallocate the node. We want to deallocate that node, right? Are you still with me? Yes, no? Okay. Question about those two functions.
So we're only deleting the contents and delete for the position?
You're deleting the address. You're deleting the address, not the lil. You're deleting the address, the node. Okay? And then after that, you reset the parent pointer to null. So remember in picture, when you try to delete that node, the incoming input parameter is the address of that node, which is that arrow actually.
Okay.
Right? So what I'm trying to do is I'm trying to put null in there.
Okay.
Right?
But
Right.
then the second one, isn't that the object, not the pointer? Line 66 there.
Line 66. This is a pointer.
Okay.
the incoming post is that box.
Okay.
Right? When I delete that, I just put a null in there because it has no children, right?
So does the delete the pointer then, or how do you did it?
Delete will delete the node. Delete will delete whatever that pointer is pointing to.
Okay.
So delete will deallocate that structure, and then post null pointer will reset that to null. The two actions are different, right? Delete will dispose the node, and then the second line will update that box to null.
Okay.
Okay? Any other question? Yes.
So after you delete it, and you don't do anything to pose, would that be pointing at the address then?
If you don't put anything to post,
Yeah. Say you didn't do that yet. So you just deleted set.
Yep.
So would that pointer pose be pointing at the address then?
yeah.
Okay.
So then at that point, post will be a dangling pointer, right?
Okay.
Because if you try to traverse the tree again, you try to go to that location, but the location is not valid now. Okay, so my find max, find min is there. We know that find min is a const function, right? And it will return a reference to the value in your tree. And I'm going to write for my find min and find max. Okay. By the way, this will be a little bit different from your textbook. So now my find max, my private find max, will take a parameter because I want to be able to find maximum or minimum from a certain location. Instead of looking for max from the top of the tree up here, the private find max or find min will let me search for anywhere, from anywhere in the tree. Okay? So now when I call find max from my public, then I will say return find max. I want to start searching from the root. Okay? So that's the find max, the public find max. And what should be the return type of find max, the private find max? A pointer. Okay? I want to return a pointer. Okay? So the private find max will return a pointer, but the public find max must return a value. So how do we translate? Star? Can I use star? Find max, private find max will return a pointer to a node.
Star find max.
Like that?
Yeah.
I'm looking for a different answer.
Everything.
Not exclamation. Return what?
Yeah.
Yeah. Question? Yes.
Just a quick question about Xcode. Why, when you were typing data, did it have the red line through it? I've noticed that when doing homework and stuff. When you're typing P arrow data. Or when you did the return,
Hit back.
it had the line across to it.
See, the data has a cross line.
Is there a reason for that?
Yes, because data is private.
Oh, okay.
Yeah, because data is private.
Okay.
Okay?
Yep.
Question? Okay. So now, I'm not going to write the code for find max. You know how to do that. Okay. But now my focus is on removing an item, right? So my remove again. In order to remove, I need to locate the node that I'm about to remove, right? So that's why the first thing I need to do is to search. Okay. Search where the node that I want to remove, and then from there, I'm going to call the method remove. Yes,
Can you
Joshua.
scroll back up to the find max and stuff?
Scroll back up. Yep.
So why is your return type a generic with an ampersand after it, and what you return is an actual value in that address?
Why the return is,
That's a value, correct, your return type?
yep,
But in the declaration of the function, it's a generic type Z followed by an ampersand.
mm-hmm.
You that you're supposed to return an address, not a value.
Because I'm returning the data pointed by my pointer P.
So the copy of data.
So P is a pointer to a node,
Okay.
right? Pointer is here, my node is here, separate. So P is up here, my node is here. I want to return the data pointed by my pointer.
So FindMax just tells you what the data is of the maximum.
The address of the node. FindMax will give me the address to the node.
The private
that holds.
FindMax will.
The
but
private,
public
yes.
FindMax will just tell you what's in the largest number.
Right, right. The private FindMax will tell me the address of the node holding the maximum value.
And then your public will just tell you what that is.
Yeah, yeah. Did I answer your question?
I think so, yeah.
Okay. Okay. Now, as far as design, I do want to disallow update, right? So I want to make that const. Because what happens if you return a reference, then if the user will update that object, it will violate the property of your tree, right? So we don't want to allow the user to change the value. So I want to use const there. Okay? Now, once you know FindMax, once you know the address of the candidate that you are about to remove, now I need to take care of that in my remove function. And let's take care of the most difficult part. How do I check whether the current node has 2 children? Tell me what to write. Pose. Left. Yep. Okay, so I know that this case pose has 2 children. Okay? And we are going to take the maximum from the left subtree, correct? Okay? And that means I need to do FindMax, okay? But I want to look for the maximum from my left subtree. And it will give me the address of that node. Max from left. Okay? Question so far? So what do? Once we find the maximum from left, what do? Let me put the picture to my right side. And remember, in coming to this remove method, we know there's an alias pose pointing to that node, right? So make sure you understand that picture, okay? So that node pose, the green box pose is pose that you see here, okay? Pose is not that box, but pose is a pointer outside of that node. Are you with me? Okay. Now, then we find the candidate, right? So the candidate here is what we call max from left, okay? And what do? We have to bring the value from here to replace the value in there, right? Okay, so tell me what to write.
Close dot right dot left equals.
First, I want to bring the value, whatever value in here, place that number up here.
This data.
Data, post data, get a copy from here. Max from left data, right? Are you still with me?
You're missing on that arrow. Or it's just
Okay? And then what is next? Next I'm going to make a recursive call because now I need to start removing from there, right? So then my next call will be a recursive call remove again, but my remove will start from max from left. We're done, right? At least to handle that part, we're done. Okay, any question? When I review my lecture again, I realized that this technique of removing from max from left will not work correctly. The reason is because find max will return a copy of a pointer to the node that we get from the left subtree, the maximum from the left subtree. What we are going to get from here is a copy of the pointer to the node. So this technique is not going to work. It's not going to recursively remove the node from here. So then the tree will contain a dangling pointer.
Max from left, right? Okay.
Yeah. Okay, so then the next case is what? When we don't have anything, when we have only one child, then what we do is what? We just say pose question. Does it make sense? What I do there? Remember, pose is the incoming, the green box. I want to update that box to point to here, right? And how do I get the address of that tree? The address of the tree is from here. And that box is pose left. Okay? And we can just repeat the no PTR. You can